Hi everyone, welcome back to another video tutorial on VAME. In this video, I want to basically go through um, the 4 steps that I'm showing you here, which is initialize project, train neural network, evaluate performance, and segment behavior. Now, I'm doing this as a part 2 to the previous video that I uploaded. In that video, at the end of the video, I rushed a bit and I did not properly show everything that I should have shown. So I'm going to make this a follow-up video to that. So I'm going to now go ahead and get started. In the former video, I showed you how to set up your environment, VAME, and how to get started with it. So here I'm going to actually um, just continue with the code. Okay, so here I have a Jupyter script that I have written, but I'm actually not going to use this. I am going to work in Python directly. So I'm first going to import. Let me initialize Python. And I'm first going to import VAME. Here is my VAME folder. I am inside of the GitHub repo that I showed you how to download in the previous video. Here I'm importing VAME. Okay, and this time I actually have my GPU active and I'm using CUDA. So training and everything else should go smoothly. So next I need to set up my working directory. And here I'm going to go ahead and make a working directory. Um, like this. Okay, so it's going to be this master VME folder. This is where my working directory is going to be. Next, I'm going to create a project name. And I'm going to call this one, let's call this YouTube tutorial 2 and videos. So the path to videos need to provide so here's one video to copy as path, put that in like that. Okay, so I'm only using one video. Obviously, if you want to use more videos, you can create a list here. Next, let's define the let's initialize a new project. So the way to do that is to do config is equal to and then call vme.init underscore new underscore project and then working directory is equal to working directory and project is equal to project like this. Videos is equal to videos. And I also need to define the video type, which in my case is .mp4. Okay, now I'm using the demo video and the demo CSV data that is provided by the GitHub repo, the VAME GitHub repo. So here we have our project is created message, and this here is the project. If I go back here, this is the project. Before I do anything else, I'm going to copy my CSV file and put it in this project folder that got created into the videos and into the pose estimation folder. Okay. Okay, so now that that is created, I need to modify my config file. and here's my configuration file. For sake of this tutorial, I'm going to change the batch size to be just 10. The maximum epochs, let's do 10 for this video's sake. Model snapshots, I'm going to do 2 here, and this will save model snapshot every 2 epochs. And basically everything else I will leave the same. So it will do 5 clusters, 15 clusters, sorry, not 5. But overall, everything else I will leave the same. Here, pose confidences, I'm actually going to change this to be 0.95. Okay, that is just my personal preference, and you should go with the preference that you have for your own project. Okay, so now that the configuration file has been modified, I need to bring the configuration file. I need to load it basically. So the way to do that is to do config is equal to provide the path to the configuration file. Copying path like this. Okay, and that is going to import the configuration file into your environment. Let's do egocentric alignment next. And for that, I need to do vame.egocentric underscore alignment. Here I need to provide it 2 things. One is the config variable, and then the other one is the pose reference index. Okay, so this basically is telling it that we have 5 body parts, and we want the body part number 0 to be the reference. So this will get going, and I'm using the confidence value of 0.95. So here I want to keep an eye on my GPU utilization and CPU. My OBS is also running on GPU, so from maybe in the next 2 steps, I might have to turn this video off, and then after training is done, I might restart the video tutorial again. So here you can see all of my frames here are getting aligned to the pose reference index. If you don't want to do this, you would have to convert CSV directly to NumPy array by using a different function. And that information was, I went over that information in my previous video. So if you haven't seen that one, please check that out. So from here on out, what we are next going to do is to skip the CSV to NumPy conversion and go directly to creating a training data set. And I'm going to do that by typing in VAME dot create underscore train set and provide it with config variable. All right, so here we go. This is my training data set, and it has been compiled. The next thing to do is to start training, and I can do that by typing in train underscore model config like this right here. Okay, so before I hit this, hit enter on this, I'm going to stop the video, and then I'm only using 10 epochs, so it should be fairly quick, and then I'll restart the video after the training is done. Okay, so the training has finished. It has finished training. Now I only ran this for total of 10 epochs. So you can see over here the training loss is quite huge, quite large. But for the demonstration purposes, it doesn't really matter. We can continue over to the evaluation of the model next. So to evaluate the model, I'm going to type in VAME dot evaluate. So evaluate underscore model, and then config. Here we go. So the evaluation of model is complete, and we can find the model stored in this folder. So within the project folder that I created, within that is a folder called model, and then the evaluate. Okay. So by the way, this is not 2020. I don't know why this is using 2020, but uh, that doesn't matter. Next, let's segment some poses, and then we can make some small videos for seeing what the segments look like. Segmentation config. So here I'm creating VAME pose segmentation, and I'm providing it configuration. Okay, so this may take a while. Okay, perfect. So all animals, the same parameterization has been applied. So this will allow us to move on to the next step, which in my case is to create the videos for each of the behavior clusters that are present in my dataset. Now, this is not going to be very fancy. It's only 10 epochs, and so it's going to be fairly loose training dataset, but it still will show you what the outputs may look like for your own data. So I will wait for this to finish, and then we can continue. Okay, here I've pulled up the actual paper that the authors have published. And one of the best things about VME is that it allows you to generate hierarchy of behaviors and represent them like you see over here in panel B, figure 2. And the other thing that this allows you to do is very easily analyze two different populations of maybe animals, or in my case I'm using mice. So two different treatment groups. For example, if I know one treatment group affects exploration in mice, and the other treatment affects maybe grooming behaviors, right? So I can explore those very easily by having these clusters, that have grooming behavior right here versus exploration right here. So it allows very quick representation, easy to differentiate representation just from one physical graph like this. So if you have multiple animals and you want to very quickly see what the different treatments are doing to your animal groups, this becomes really useful, handy tool. And the VME also provides a lot of different visualization tools. I'm not going to go over all of them, but this hierarchy map, I will demonstrate how to make this. So in my back in my Visual Code, I'm using again Python, and my videos, the different clusters have finished, and these are the video outcomes. And here you can see the mouse is a little bit faster in walking. So it's very hard to see what's happening, but the mouse seems to be sniffing around. Here's a cluster 6. This is obviously a rearing behavior getting picked up. Okay, so it's a very easy way to differentiate, but there's another easy way. Okay, here's the hierarchical tree that gets generated. So here, if we compare, for example, here is the k-mean clustering. I didn't run it for enough epochs, but regardless, you can see there's a root over here which branches into different subtypes of behaviors, and each one of those has different subtypes even further broken down. Right, so here I don't know if I can draw on here, but okay, regardless, you get the idea of what I'm trying to say. So each one of these is a subtype of a behavior, which you can then further refine or cut off. Well, guys, my computer has officially frozen up. There are too many computations going on, so I'm going to end this video right here. But the last few things that I wanted to show you are on the GitHub page, and those are the optional things. So I've already shown you that you can create the behavioral hierarchies using this command right here. A few other things to mention is that you can define where you want the cutoff to occur. The other thing that I wanted to show was the visualization here. This one, and it creates a NumPy array, and then you can visualize it as a 2D UMap. But my computer has decided that it's not going to cooperate. But overall, these are very easy, simple one-line things. You provide it with your config file and one of the options here, for example, Moti for community, and it does the rest for you. Now, these for me are taking very long and they are CPU dependent. So make sure that you have enough CPU available and you're not running some other CPU dependent task while you do this. This is another good one, but this relies on you creating a GIF using ImageJ or some other platform. But this will extract the frames for you so that you can create a GIF for yourself. So overall, that's basically what I wanted to show you, which are the steps 1 through 4. Quantification of behavior is really up to you. Once you decide which behaviors you want to keep, you can quantify those behaviors. Overall, that's it for this video. Thank you so much for the feedback that some of you gave me on the previous video. I really appreciate it. Thank you so much. Bye-bye.